going to go through them algebraically. You can solve them with your graphing calculator. No, this one down here is not. Okay, let's look at a couple of these. Where would you like to start? On what? A, B, or C? Pick one. C. Okay. Okay, let's start with 1C. We want to get the same base, so who do we probably want to change? 81. We want to check. Can we write 81 with a base of 3? So you're 3 squared. You could try 3 to the cube. Nope. 3 to the 4. Bingo. We got a winner. Yay. Okay. If we don't find one, guess what method we have to use? If we can't make them the same base, graphical. Like if you had one base of 3 and one base of 5, like you just can't make them the same. Okay, that's where we're going to learn about logs. Yeah. Okay, so 3 to the 4. Now when we replace it, what do we want to do? How do brackets? So inside is 3 to the 4 and outside is 3x. And a power to a power, we times them. See, you guys know your exponent laws. So 12x. So now we can conclude 5x minus 1 equals 12x. Situation like this, we want all the x's together and all the numbers together. So who do we want to move first? 5. Now, 2 terms here. So what are we going to divide or are we going to subtract? Subtract. Subtract 5x, subtract 5x. We got negative 1 equals 7x. And last step, divide by 7. Only when it's a monomial do we divide, because this is multiplication. We're always doing opposite operation. So negative 1 over 7 is our x. Okay. Anyone have trouble with D? Okay, I like D. Just because it's a question that has like almost everything in it. So it's a tough one. Okay, I'm sorry. All right, we want to make a base of 3, and everything has to be in exponential form, so we can't have square roots. So 3 to the x, how can we make 27 base 3? 3 to the power of 3. 3 cubed. Times. Now we want to get rid of the square root. We want it as an exponent. So remember with these guys, what's his power here? What's 1 and what's his is root? 2. So this becomes 3 to the power of 1/2. 1 over 2. Now what exponent law are we going to use next? For multiplication, what do we do with our powers? Add them. We can make it a decimal if you like. So with the same base being multiplied, we add our exponents. 3 plus 1/2 is 3.5. So therefore, what's x equal to? 3.5. You add when we have the same bases being multiplied, we add the exponents. Okay? it's really no, but we had the exponent. We had the changing our square root to an exponent is tough. You have to remember to add here. Okay, let's look at G. Is this an exponential function? No. Why is this not an exponential function? Because you don't have x in the exponent. X is not in the exponent. So solving for x, it should be easy if it's not an exponential function. Says me. Okay, so let's start with getting x by itself. What's happening with x? It is. It has 2 things, right? It has a power, and it's being multiplied by 3. How do we get rid of that 3 it's being multiplied? Divide. Divide both sides by 3. Okay, so that's our first step to getting x by itself. So now we have x equals, or x to the power of 1/3 actually, equals negative 2/3. Now, what is x to the power of 1/3? We can change it. When we have a fractional exponent, what does that relate to? Roots, yeah. Fractional exponents basically are radicals. They're radical, man. Okay, so so his power would be what? And his root would be what? Power of 1, root of 3. Power over root. How do we get rid of what's the opposite operation of cube rooting something? Close? Opposite operation of cube rooting. Okay, what's the opposite of square rooting? Square. Square both sides. Opposite of cube rooting then would be to cube both sides. Okay, so -2 cubed, -8, 3 cubed is 27. I thought oh, sorry. Oops, cubed. Okay, well, will you see many questions like this? Probably not, because the focus is on exponential functions. So more likely, what would be important about this is to know that this is not exponential. So on a multiple choice, I'll ask you which one of these is an exponential function, right? Okay, 2, how do we solve this guy? Can we make these bases the same? No, so we're going to go left side is y1, right side is y2. Okay, type her in. 2 to the power of bracket x minus 1. I'd rather be hearing that from you than the opposite, because I know I can go too fast. Right, so how do I reset the windows? Zoom 6. Thank you, Jesse. Okay, so we should see, woohoo, 2 things. Okay, we want to find the intersection, so second trace 5, 1, 2, 3. Push enter, because it's thinking you paused it. Okay, and so x value would be what? 3 point, did you guys get the same thing? 7, 1, or 3.7. Okay, so we go, if this was a test, you'd actually have to write out, like it says, describe. So I said y1 equals this. I said y2 equals this. You're writing that all out. I go second trace 5, enter, 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 gave me the x value. The intersect is the x value. Here's my answer, right? You'd write that out. Okay? All right, let's look at this last question before we're free to go. So your quiz will be tomorrow instead. Okay? So let's look at this guy. So this is pulled directly out of the diploma exam. People release this as a possible type question for a diploma exam. Okay? A researcher discovered mold growing in a petri dish in her laboratory. When she first observed, the mold covered only 3% of the dish surface. Every 24 hours, the surface area of the mold doubles in size, as shown in the table below. Okay, so did you fill in the table? So every 24 hours, it becomes double the amount. So at 48 would be 12, and then 24. Okay, so if you were to roughly sketch this, it might help you. Well, you're going to have to sketch this. It's going to help you figure out the A value and the B value. Okay, so I'm going to sketch it down below, actually. So our time is always on the bottom, and we have 0, 24, 48, and 72. Okay, and then here our percent is 3, 6. Okay, so percent always goes up to 100%, right? 10, 20, 30, 40, 50, 60, 70, 80%. Roughly. So we're just doing a rough sketch. So at 0, we are at what percent? 3, right? So down there, this is 3. 24 hours, we're at 6%. 48, we're at 12%. And 72, we're at 24%. That's an exponential growth. Oh, it's, okay. 24. It is an exponential growth. Okay, so what would be my A value? What's my A value? What's my A value, guys? 3. Why is it 3? That's your y-intercept when x is 0. Okay, what's my B value? What's happening every time? Our B value is what we're multiplying by each time. Times 2. So my B value is 2 because we are doubling. So if it's halving, it'd be 1/2. If it's tripling, it would be 3. So my equation, what would be the equation of this then? Y equals 3 bracket 2 to the power of x. Okay, domain of this function. Yeah, be careful. It's a word, it's an actually application problem. So would you have a negative time ever? No. Right? So it's above 0. So our time is greater than or equal to 0. Our range value, our range up and down. Our percentage, which we'll call, I don't know, y, I guess. Oh, what did they use? First area, A. Okay, it's greater than 3. In fact, it's between 3 and it's a percent. 100. So it's between 3 and 100. Because you can't have more than 100%. So greater than 3, less than 100. Yep, could be equal to 3% or it could be equal to 100%. All right, so the last question, it says, you basically are solving for when it's 100%, when it's full. So you'd have to use y1, y2. Okay? Want to go through it really quickly? Y1 would be 100, and y2 would be 3 times 2 to the power of x. I'm going to put brackets here. Did anyone solve this already? My windows are going to be bad because we have up to 100. So I'm going to have to go for y up to like 120 so I can see that. Yeah, y max. Second calc 5, enter, enter, enter. And we get t equals 5.1 in hours. Here's my intersection, okay? So I hope everyone's feeling a lot better about everything at this point.